Today we're going to talk about inequalities. So the first inequality that we're going to talk about is less than. Some examples of less than can be written like this. X is less than 0. Now, whenever you read this, you always read it from the variable. So sometimes the x might not be on the left-hand side, but it might be on the right-hand side. And if that's the case, it would be x is less than 0. Both of these mean the same exact thing. Some key words for less than are fewer than, below, and even the word smaller than. When we go to graph it, we are going to do an open circle. So that would be an open circle. And since it is less than 0, we would go to the left. So that is the first example. Okay, the next example is less than or equal to. So one way you might see it is x is less than or equal to 0. But remember, x might not always be on the left-hand side of your inequality. It might be on the right-hand side. And you read it from the variable. So x less than or equal to 0. Both of these mean the same exact thing. Some key words for less than or equal to are at most, no more than, does not exceed, not above, and lastly, is not greater than. When we go to graph this, it is going to be a closed circle. Now, the reason why it's a closed circle is because it has the equal to. So when x is less than or equal to 0, it is going to go to the left because it is less than. The next one is greater than. So the way that we can write greater than is x is greater than 0. But remember, the variable might not always be on the left side of the inequality. So if it's on the right side of the inequality, it would be read like this. X is greater than 0. Some keywords are more than, above, larger than, and exceeding. When I go to graph this, it is going to be an open circle. And since it is greater than, it is going to go to the right. The next one is greater than or equal to. So when you write this, you have x is greater than or equal to 0. But remember, the variable might not always be on the left side of the inequality. It might be on the right side. So it would be x is greater than or equal to 0. Some key words. At least, no less than, not under, minimum, no smaller than, no fewer than. When we go to graph this, it is going to be a closed circle. The reason why it is a closed circle is because it has the equal to, and it is going to the right. All right, so the last one, meaning not equal to. So we could write this as x is not equal to 0, or we could also say x is not equal to 0. There could be several different interpretations of this. If we're just talking about whole numbers, we could say if it's not equal to 0, it's everything besides 0, where it's greater than 1 and less than -1. But you would even have to take into consideration decimals and fractions and stuff. But this is one interpretation of it. There's many others. But it's just x is not equal to 0, meaning this is not a number that's used. Okay, let's go to 8.3, writing two-step inequalities. All right, so some of this vocabulary we've already done. It says inequality is a mathematical sentence that shows the relationship between quantities that are not equivalent. Less than is fewer than, smaller than, below. Greater than is more than, larger than, exceeding, above. And those are both open circles. So I need you to know that less than and greater than are open circles. The closed circles are less than or equal to, which is no more than, is not greater than, not above, does not exceed, at most, maximum. Greater than or equal to is no less than, no fewer than, not smaller than, at least, not under, and minimum. These are both closed circles. If I look at the first inequality, this is going to be an open circle, and it's going to the right, which means it is greater than. So the way that I write this is x is greater than 0. This is a closed circle. It's going to the left, which means it is less than or equal to. X is less than or equal to 0. X is at least 36. The word at least makes it a closed circle, and it's going to go to the right. So it's greater than or equal to. So greater than or equal to. If I was going to graph it, I would have a closed circle, and I would go to the right. X is no greater than 24. No greater than is right here. So that is going to be less than or equal to. So if I was going to graph this, it would be a closed circle, and it would be going to the left at 24. All right, let's look at example 1. A mountain climbing team is capped at an altitude of 18,460 feet on Everest. That's my B. That's my flat one-time amount. The team wants to reach 29,029. That's our ultimate goal. That's our why. And we want to do it within 6 days. Our constant rate of change is 6. And we want to write an inequality to find the number of feet per day the team must climb to accomplish it. So the feet per day is the 6. That's the 6 days, and we want to know how many feet we have to do in that time. Well, when we do this, we write it, you could write it in the y equals mx plus b format. But now instead of the equals sign, we're going to be using an inequality. So we're going to say 6x plus 18,460. Now the new part is the y. The 29,029, we want to be greater than or equal to. So when we do this, another way to write this was the starting altitude was 18,460. The number of days was 6 times the number of days greater than or equal to 29,209. And if you want to write it in the y equals mx plus b format, it would be 6d plus 18,460 greater than or equal to 29,209. All right, flip it to the back side. So on the back side, it says the members of the Glee Club are trying to raise at least $6,000. My total is the Y, the $6,000. And the vocabulary word that we need to take into consideration is at least. So they compete in the state championship. They already have 1,240. That's the starting 1,240. That's the B. And what inequality can you write to find the amount each member must raise? Well, each member is the constant rate of change, and there are 45 members. So if we are writing it in the y equals mx plus b format, it's 45x plus the flat one-time fee. And now the vocabulary word at least makes it greater than or equal to 6,000. All right, let's go to the last one, example 2. All right, so in example 2, it says, write a corresponding real-world problem that represents 2x plus 20 is less than or equal to 50. So we can go down to the bottom, the first one. Thomas has run 20 miles so far this week. If he intends to run 50 miles or less, how many days on average should he run on the 2 remaining days of the week? The M is the 2 days. The B is the 20. The Y is the 50 miles or less. So when you write it in the equation or the inequality format, it's 2x plus 20, and you want 50 miles or less, so less than or equal to 50. Okay, the last one. Manny buys 2 work shirts that are each the same price. After using a $20 gift card, he can spend no more than $50. What is the maximum?